to get a job writing software for fake bombs in the movies, we're going to have to know how to use for loops. In fact, for loops are an essential concept in computer science. So let's see how they work and how they differ from that loop method we've been using since the start of this course. So here's the program we started the course with. It just blinks the LED on and off, and it's in that loop method, and that means it repeats forever, right? It blinks forever. As long as we're supplying power to the Arduino, it's blinking. Let's look at another example. So here's a counting program. It starts at 99, and every time through the loop, it'll print the number, and then it'll decrement that counter. So counter equals counter minus 1, so then it'll be 98. So let's see how that works. Maybe that's the beginning of some sort of scary thing we can write. So let's load that in. It's uploaded, and let's look at the serial monitor. And that's a good start. It goes down and down. And it just keeps going, right? It never stops. It just keeps subtracting 1. So it'll keep generating negative numbers forever. And what we'd want instead, perhaps, is that when we blink an LED light, we'd like to blink it maybe exactly 5 times or exactly 10 times. Or when we're printing out numbers, maybe we just want to print out 1 through 10 or count down from 10 to 0. So that's what a for loop is for. It enables us to cycle through things a specific number of times. So let's see how that will work. So here I am back with blinker, and let's say I want to blink the LED 5 times and then wait a while and blink it at 5 times and keep doing that, but we want to blink it 5 times in succession. I'm going to keep these few lines here for later, but the general syntax is we're going to have a for, that's the name of the for loop, and we have to declare a variable, so it's going to be an integer, and it can be anything we want. We can have it foo, Ralph, Ann, whatever, but a general convention is just to use a single letter like I or J, and it's going to start at 0, let's say, and then we say when we should continue doing the loop. Well, as long as I is smaller than 5, we're going to do it. And then I'm going to increment I. So, and that syntax is this. I++ means we just add 1 to I. So this is going to do a loop. Well, let me put it in the body here. So whatever in the body, it'll go 0, I is 0, 0 is less than 5, so it'll go within this body. And then now I is 1 because we increment it. And then it'll do the body again. So now that's what I'm going to do. All right, so I is 0 to start with. It does this blink. Then it comes back up to the for loop here. So now I++, so I is 1. 1 is less than 5, so it repeats this loop again. Now at the top, we add 1 to I. I is 3, we repeat, because 3 is less than 5. Now we add 1, I is 4. We repeat this. We add 1 to I now is 5. 5 is not less than 5, so we stop the loop. So let's say just at the end we delay wait times 5. So we wait a bunch of time. All right, so let's try that. One, 2, 3, 4, 5, pause. 1, 2, 3, 4, 5, and pause. Okay, so that seems to work. So we can repeat something a specific number of times. So let's look at the syntax again. So this part here is the starting condition. We declare a variable, an integer, and we give it a name, I, J it could be, or we could give it anything like Ann, Ben, Clara, but I is a convention. So we're starting at 0, and this tells us when we should go in the loop. If this is true, we do whatever inside these braces. So I is less than 5. And this tells us how to change I. Right? So this says we should increment I. If we wanted to subtract I, which doesn't work in this case, it'd be minus. Whoop. All right, Let's go back to our counter program. Here that is. And let's say now we want to just count up from 1 to 10, and we're going to stop. In this case, if we only want to do something once, I'm just going to do it here. I'm just going to do it in setup rather than in the loop, which goes forever and ever. And let's see if we can do this. So I want to start at 1 and count up to 10. So how we do this is we have 4. I'm going to use I again, and we'll set it initially to 1. So we start at 1. And this is the test of when to do the loop. Well, I is less than 11, let's say, because we don't want to do 11. And we'll increment I. And now what we'll do is we'll print it out. Serial print line. And that looks pretty good to me. Let's give it a try. Okay, it printed. Let me hit the reset button. And it prints 1, 2, 3. Let's actually slow it down a little bit. See if we can do that. Let's go wait and change wait to 1,000 once every second. All right, let's give that a shot. That's looking pretty nice. And let me hit the reset button. Okay, that looks good. Let's try something slightly more interesting. Let's say we want to do the famous 100 bottles of beer on the wall thing. So let's go start at 100 and work our way down. So for int, we don't want to start at 1, but we want to start at 100. And we're going to keep going while I is greater than 0, let's say. We don't want to do 0. And instead of I++ here, every time we're going to subtract 1 from it. So this means subtract 1 from I. So we're going to print. Let's just keep it simple and not do that whole verse. So print I. And let's hurry it up a bit and just do 200 here. Right, so we start I to be 100, and we keep doing the loop while I is greater than 0. And we keep going I minus minus, subtract 1 from I. All right, let's give this a try. Not a very exciting program, but we get the idea, and let's see if it indeed stops. And it did stop. And let's say we want to say no beer left or something at the very end. So let's see how we can do that. So here's that for loop, and it ends there. So as soon as the for loop's over, it's going to continue on. So let's go serial. No beer left. Doesn't seem like the type of thing I should be printing. But let's go with it. And just for brevity, let's just start at 10 bottles of beer. All right. No beer left. All right. So that's the idea of for loops, right? So the main critical component is this up here, where there's 3 parts to it. The first part is here, right, where we initialize something, in this case, an integer I equals 10. This next part is when to do the loop, or when to do what's inside there, when I is greater than 0 in this case. And the last component of the three is how do we change I, or this variable that we set. Remember, we could put j here. Makes no difference, it's just a name. And I made a mistake there, but you get the idea. So I hope this was useful in understanding for loops. Let's go on with a different example. So let's put aside this unit, which has 1, 2, 3, 4-digit 7-segment display. This is in our kit if you're interested in playing around with it. And look at something a little bit simpler, which is just one 7-segment display. So let me just kind of get that in focus, hopefully. And as you can see, it has, I don't know if this will work better this way, it has 5 pins on each side. And let me explain this unit a little bit better. And let's look at those 7 segments. So there's one segment up here, and just to keep track of things, I'll call that A. This is B, C, D, E, F, and there's a decimal point. So that's the layout. So you can see these are the general convention of names of the different segments. And if you wanted to get a 0, whoop, I missed one. That's G. If you wanted to get a 0, you would light up A, B, C, D, E, F, not G or the decimal point. And if you wanted 1, you'd probably do B and C. So these are the names of the segments. Now let's look at the pins. There's 5 of them on each side. And these middle ones are called a common cathode. They are connected to the negative pin. And each of these others refer to one of the segments. This is A, B, this is the decimal point, this is C, D, E, F, and G. So those are the pins and how they're connected to these LED segments. Now, each of these segments is just a simple LED. So if you wanted to turn B on, you would do digital write, whatever pin that's connected to, high. If you wanted to turn B off, it would be low. So let's experiment with that for a minute. Okay, and here I've done some preliminary wiring on that 7-segment display. So the COM here and on the bottom, I've connected with resistors, just like we would do with a single LED. So you can see the middle pin there on both sides is connected to ground. That ground is connected to my Arduino. I have a loose lead here that's just connected to positive, just so we can illustrate things. So we see that we have A is the pin up here right next to that resistor, and B and the A segment is the one on the top. So let me light that one up just by applying 5 volts, and there's that one. The one next to it to the right should be this segment, oops, sorry, on the side here. Let me show you that one. There it is, and so on. C, if I went to light up C, it would be the one to the right of the resistor. Let's do that one. There's C. And if I wanted to light up B and C, I guess I'll need another wire. Let me connect this to positive. I'm going to connect one to B. And then I'll connect one, oops, sorry, And then I'll connect another to C, which is down here. And I got a 1. So with this information, I think you have enough to make a countdown timer that would go from 9 to 0. And let me demo that. Okay, and here's the challenge. Can you make a circuit like this that has functions like a function for 0 to display a 0 on this pattern, a function for 1, and so on, and it has a for loop that'll count down from 9, and every second it'll display, let me plug this in. Every second it decrements. And then when it gets to 0, it'll blink 0 and a vertical and a line 10 times. So there are 2 for loops. One that does this countdown. And one that does that 0 blink. So the countdown for loop isn't the most efficient. We don't have enough programming fundamentals rudiments to make it efficient. We will shortly. So it's kind of kludgy, but at least it's a fun exercise. Remember that the 7-segment looks complex, but each segment is just an LED, and you know how to turn on and off LEDs. Okay, and I just wanted to show you a few helpful hints. So we're writing functions like this, a function for 0, a function for 1, right? And we say, those segments A, B, C, D, E, and F are all on. G is that middle section, and that one's off, and that defines as 0. So that's what we're doing. We're creating these functions for the digits, basically 0 through 9. You'll also need a function for pretty much everything off in order to do that last pattern. Now you may think there's probably an easy way of doing this, which would be you'd write then in loop or in setup, you'd just write 9, and then you delay maybe the wait time, and then you do 8. That seems, for what we know, probably pretty efficient. We'll see later that there's a better way of doing this, but that looks reasonable, and it doesn't look kludgy, right? Whoops, I misspelled 7 up there, but you get the idea that we could do this, but that's not what I want. What I want is a practice in for loops. So we're kind of doing something inefficient just so we get some practice and build up some experience with for loops, and that we can make more efficient programs later. So I'm hoping that makes sense to you. It looks more complex now, but it's really kind of a stepping stone to ease. And here is another little clue. So within that for loop, there'll be a bunch of if statements, something like this. So if the digit is 1, you'll do the procedure 1, else if the procedure is 2, you'll do or if the integer is 2, you'll do the procedure 2, and so on. So that's all I wanted to explain to you. It's kind of an interesting, fun challenge just to work with those 7-segment displays. I hope this was all helpful and fun. Take care. Bye.